Okay, this is how quantum mechanics works. This is an electron. This is the nucleus. It has an extreme positive, which wants this electron in here, but it also has negatives in the core, which repel that. So let's watch. Boom, look at that. You see that? It's doing both. It's pulling and it's pushing. Now, all more electrons will try to get to there. Now, what he's going to do is start to shake that. When he shakes it, this rattling is what we call heat. And if he shakes it hard enough, it will displace itself, and that is what we call light. That's heat. Boom. That's heat. And that's light. Hello, my good friends. It's Roger, Mud Fossil University, here being held to planet Earth by gravity. And now, today, Mud Fossil University explains gravity. And it is easily explained when you remove neutrons. That's all you have to do. Just say neutrons do not exist. Then go from there. Simple as that. Now, this is what atoms look like. Most people understand that. They don't really understand the sizes. A proton is not the same size as an electron. You see, these are all electrons out here, and these are protons and neutrons. And neutrons don't exist, so we're going to talk about that in a second. But the proton is 1,800 times bigger than that. You wouldn't even see that electron. However, that electron has the same voltage as that huge proton, is what they say. Okay, so what does that mean? It means there's 1,800, okay, I'm sorry, let's back up. What it does mean is for every electron, which is the tiniest particle there is, supposedly, which I have found out is not, and I have 100% evidence to prove that in pictures. This is supposed to be the tiniest particle, and I am saying that these neutrons are not neutrons at all, not whatsoever. There is no neutral particles in the universe. None. Zero. Zero. These neutrons, throw them right out of here and replace them by flooding the protons with what they want is electrons. Obviously. Neutrons don't just go bouncing off into rolling around on the floor. They are just not neutral, and they are not there whatsoever. They just don't understand it. The protons become flooded with the equivalent negativeness. So for every one of these, 1,800 of these come into the nucleus. All right? Every tiny little particle like this is all there is other than the big ones. And the big ones are 1,800 times bigger than the little ones. The little ones are minus, the big ones are plus. The little ones go squishing in here and cuddling up as tight as they can get into those pluses, and then they build a field around the new ones that want to come in, and they say, oh, no, we got all we want in here, you're going to have to stay away. And they say, well, what are we going to do? So we'll just hang out there. Just wait out there, and then the next guys come, and they say, what are you doing here? I said, we're trying to get in there. And so, well, what are we going to do? You're going to have to stay up in here, that's all. And the next guys come in, same thing. They stay. Now, it depends on how many guys are in here as to how many guys will line up out here. Case closed, that's all it is. If there's 10 protons in here, is what they claim, there'll be 10 electrons out here. All right, now the neutrons are a little bit different. The neutrons, they claim, which I'm saying replace that with 1,800 electrons where there's every neutron. Every single particle, which is a proton, will have a full complement of electrons attached to it. All right? except hydrogen. Hydrogen was the one that had me going. I just couldn't figure it out, but it fits in elegantly, and we'll talk about it in a minute. Now, so you have a whole ton of electrons in here, and then you have your positives offsetting them, so that becomes basically neutral with a smidge extra negativeness, because it shows it up too in the masses. The protons are a little bit less mass than the neutrons. The neutrons are just a little more negative bunches of electrons, which creates a negativeness surrounding it, and then they all line up around themselves, which is what I talked about before. So forget neutrons. They do not exist. Absolutely do not exist. And everything else works out perfectly. And hydrogen does too. All right, because hydrogen will have only one proton in there. And one proton equals one electron. All right, the one electron that hooks up to it is 1,800 times as strong in 1,800 times smaller than the proton, but it's the same charge. And that's why one electron hangs out here. That's why you have hydrogen. That accounts for the singularity of one proton, one electron, one in the orbit. Two protons, two electrons, two in the orbit. All right? That's the way it works. And something to remember is that hydrogen only has one here and then only one here. Everything else is gone. One proton with one electron attached to it for the core, and one electron out here, and that is anti-gravity. Because the negativeness of this is not sufficient to be pulled to the positiveness of the Earth. The positiveness of this one proton exceeds the negativeness pull, and that is anti-gravity. That's why hydrogen goes up in air, and the same thing with helium. Now once you get into lithium and the other elements, you begin to get, they're light, but they still are attracted to Earth. They're in that pull and not real hard pull zone. That is what the whole story is here. It's magnetism. It's magnetism. And the more electrons in the cloud, the heavier it pulls, because the more electrons in the cloud, the heavier the core is. The heavier the core is, the more positive there is. The more positive it is, and more negative will be surrounding it, gets pulled to the Earth. Because you not only have the negative surrounding it, but you've got negatives in here 1,800 times every one of the positives. So as you increase in weight here, it increases exponentially into the pull of the Earth, because the weight of it increases due to the electrons. The electrons literally are the weight of things. Well, actually, the electron ratio to positives is the weight. I mean, that's what it is. Okay, this is a very, very basic, simple explanation of what an atom is, and an electron, proton, and what they call a neutron, and then about the atomic number. Very, very simple and basic stuff. Now, remember, there is no neutron. None. However, look at this. They say that the neutron is 1,842 times the size of an electron. And an electron has the same charge as a proton. All right? So there's 1,800 electrons for every proton. All right? Same charge on each one of them. So 1,800 times as powerful. Now, my atomic model says that there's 1,800 of those flooding every single proton in the nucleus. And when it's all compressed and those little particles fly out of there, because they're the weak ones, they're the ones that want to leave, under a fusion explosion, in a fusion condition where the deuterium and tritium, those two compress together, and it liberates one of the neutrons, which is 1,800 times an electron. So in a fission explosion, you're just liberating little electrons, and dozens of them here and dozens of them there. A lot of them, I mean, a ton, I'm saying. And it's huge, obviously. However, in a fusion, it's 3 or 4 times the same amount of electrons are being expelled, and obviously the same amount of power. So that's my contention. Roger once again, Monopoles University, back in the light realm. Now, this is the classical depiction of a light ray. And this is by physics videos by Eugene Koyansky. And it's polarization of light. And he gives an excellent representation of what the current thinking is on light. Now, they consist of what they're calling a field and, well, really what I'm calling a field and a particle. And now it's called the Higgs boson, I believe, is what we are going to be looking at, which is the particle, which is a monopole, electron, negative electron monopole, spinning through space, creating a field around itself as it goes forward. That is the Higgs field, and the particle is a boson. Now, this is interesting, and we have a depiction showing the same characteristics in actual physical light in the air. Now, watch what this does. Let me turn the sound on. Well, I don't know. Let's leave the sound and see what it says.
Of electric and magnetic fields.
Here, let me start that over again.
Which challenge our assumptions about the nature of reality. In classical physics, light can be thought of as a wave of electric and magnetic fields.
The electric and magnetic.
Suppose that we have 2 of these electromagnetic waves in the exact same region of space. At each point in space and time, their electric fields will add like vectors. And their magnetic fields will add like vectors.
You see how it's growing a field around it in layers? Well, I'm going to show you what we have found in our experiments. Now, this is very similar to what they were showing. Do you see this spinning particle here? That is spinning to the right, which means that the particle will drift to the left. And it's quite obvious we're seeing it spin, and we're seeing these separations in the fields. And I believe we're seeing the strobe effect of the particle, that it is really just a single particle. But the way the camera takes the picture, we're seeing it as it rides the top of the wave instead of as a singular particle. But the drift is obvious. So it is spinning to the right, drifting to the left. You can see that it is compressing. You see the width of the bands here, and they have compressed down here. Now, so that appears to me like that additional wave, first wave coming in. And then they showed where the waves rode each other, and then you ended up with the fields. And I believe these are the Higgs fields, which ride these white electron trails as the field, and this is the charge carrier. So this is the charged field, and you can see it's charged. You see all the little dots, dot, 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 dot. They all have dots all over them. Those dots are polarized ether, and in the air is free floating electrons. They're just free floating around in the air. They try to attach to water molecules when they can. If they can't, they'll attach to you. That is their nature. They float around in the air. And if you ran a wire through the air and put a piece of paper on it and threw some magnetic filings on there, they would ride the ether around that wire and show up just the same way as this. Because this is nothing more than electricity in the air. Light is electricity in air. That's all it is. So light is every electron spinning through air creates a magnetic field as it passes by whatever it passes by. And if there's ether there, which is these polarized molecules, they will form a pattern around the head of that particle as it trails off. That's what we're seeing. I believe they're calling this now the Higgs boson. So this is the boson particle headed by the Higgs field. All right, what you should do is go up here on my YouTube channel. So unified theory works because the new atomic model has no neutrons. And I show the actual light experiments we did. And I'm showing the magnetic fields that are on the head of these little tiny particles. And this is light coming out of our accelerator. And this is light without acceleration. And this is light as it is accelerated through the accelerator. It turns atomized white. And this is light coming out of the accelerator in its chaotic condition as it settles down back into its red spinning disks. And this is the coup de grace. This is a light field, magnetic field from the head of a light particle, which these could very well be the Higgs bosons, because these are light particles. These are the smallest particles that exist, supposedly, although that throws a real big hammer in the middle of things. These supposedly are light particles, and the particle is in the center. This is the field. So the particle is a monopole, means a negative mass, spinning through space. As it moves through space, all of the particles that surround it, which is the ether, which are the free-floating electrons, they set up a field around that charged particle. That is the nature of charged particles. When they move through anything, they create a field around itself. It's just fully understood. And that is what we're looking at. Now, what else are we looking at? When we came back to here, let me show you here. This little white particle that came out from the accelerator here is high energy. And what that one did was it created this. All right, that's the high energy particle, and it smashed into this wave. You know, this magnetic, these are magnetic fields. So the field bumped into the field. It's like two magnets bumping into each other. And it forced off a mini magnet particle, which is a piece of light. That's all I can tell you. It's a piece of light. So now, that, I just showed you some pretty serious stuff as far as light goes. Now, let's go back to the gravity. So remember, this is the key. In the core, all you have is positives that are in a little lump, and they are being tried to be infested by electrons, not neutrons, electrons. And the electrons are so tiny that 1,800 of them make every one of the protons. So, but they have the same magnetic charge. That's the key. Each one of them in 1,800 times as powerful as the proton. So each one of them has the same amount as the proton, and there's 1,800 on each proton. So if you have 5 protons in there, you have 5 electrons, let's say, well, 5 electron masses, which are 1,800 times 5. You got almost 10,000 exactly the same charged particles that can be exploded out of here. And they can be exploded out of here quite simply, and that's exactly what they do with nuclear weapons. They force everything in so tight that they're in there, everybody's in each other's regions. And what you end up with is a repulsion that is so extreme that all of the electrons literally leave. And that's the brilliant flash of white light, and it burns everything and gives all the radiation sickness and all that business. Instantaneously, it's just... And these are going, I mean, there's just so many of them. Now, some of the nucleuses, I'm sure, the nuclear particles, the protons, will crack, possibly. I don't know. That I can't comment on. But I can tell you one thing. There is so many of these in here, And there's so many out here that when those explode, it's all over. Now, these are what happens in a fusion bomb. And there's thousands and thousands more of these in here than there are out here. In a regular, I'm sorry, in a fusion bomb is the one that the particles fuse together. And every time they fuse together and make a smaller particle, they liberate like 2 or 3 times as much as they put together. And that's what they say, they have about 4 times the power of a fission bomb. And a fission bomb is just that everything collapses here. The nuclear cores remain because there's just not enough compression to turn them into a plasma so that the protons float around and can get really tight and hit each other and stick. But all the electrons go. So then you end up with a positive core. And it's very simple to see because the positive core pushes away from Earth's positive core. Earth pulls everything in because every single thing there is full of electrons. Everything there is, every single thing. The only thing that isn't is something like this when they do a nuclear explosion. I'll show you what happens as it pushes away from Earth. Okay, this is a nuclear explosion, and I'm going to explain to you how they create a nuclear explosion and what the result of that nuclear explosion is. Anti-gravity. Now, this is by Corrosio, and this is a nuclear explosion. Now, let's just watch and see what happens here. All right, this is not a good thing. This is all the bright light coming off. Now, watch what happens. Here's where the core is here. There's the core up there. Nothing happened down on the ground now. All of that stuff is gone, the shock waves moving, the core is going up here. And why is it so brilliant and bright up here? It's trying to pull the electrons back into it. All those electrons have been pushed out, and now it's pulling them back in. And that's why it goes straight up in the air, because it's a positive mass now. The electrons have been liberated straight up in the air. That's the key. All right? Watch, here's another one. Look at it go straight up in the air. I mean, how could anybody miss that? There is the mass now. It's being pushed away from the Earth. All right, so this is to wrap it up here. The nucleus is protons, and they are flooded with electrons. That's all. There is no neutrons. All electrons are attracted to protons. They will immediately try to find protons, and there are so many electrons that saturate the universe that they always are attached to protons. They can find protons because there's always an excess of electrons, it appears. Now, neutrons just don't exist. All electrons will seek complete matter. The electrons want to find a positive. It's just like a magnet minus wants to find a magnet plus. It's just the way it works. All complete matter has electrons. All complete matter. Now, this is the key. Every single thing that you see here is coated with electrons. And it is coated inside with electrons, every single positive particle, which is the protons. They have been invaded by electrons. So it is saturated with electrons. There are some nuclear configurations that create certain magnetic properties that allow them to be magnetic or repel them, they do all kinds of things. But it's a product of how that nuclear negatives and positives have arranged themselves. Simple as that. And how many there is in there hanging around in their very outer orbitals, how toughly they're stuck, and if they want more to come in and hook up with them, that type of thing. That's how bonding occurs. So let's get right to the bottom line here. All matter has an electron. So that means all matter is going to be pulled to all other matter. They all have matter because all complete matter has protons, which is a positive. So all electrons are going to seek all matter because matter is complete. So all matter accumulates more positive pull as it keeps building and building and building and building and building. We understand that. The magnetism, it gets stronger and stronger. The gravity gets stronger and stronger. We call this matter gravity. Case closed. That's gravity. Okay, I know what you're saying is, what is the source of all this ether? What is the source of all these electrons? Why are all these free particles floating around as light and ether and collecting on people's bodies as static electricity and so forth? Well, the reason is the sun shakes so violently because of its crushing amount of mass that it spits out electrons and other things too, but primarily electrons. Now, when those electrons are in space, they're spinning little monopoles, and it appears that some of them, they take off, and some of them just sort of drift off. It depends on those little, you ever see the little tails that run on, they slam and they smash and so forth. Well, some of them come out and they whip. Well, you know, they're going to shoot them at different rates. I mean, it's just as obvious as that. Now, so the spin will be different. Now, that spin is a frequency. The speed is probably different too. All right, so what that indicates is when they hit something that has matter, because right here in this space, there's nothing here that has any nucleuses, okay? Do you understand me? There's no nucleuses, so there's no clouds of electrons around nucleuses for these little particles to bump into, so they don't react, because they're all negatives out here. In the vacuum of space, there's no complete matter until you hit the space station or some debris out there, and that'll light up. You can see that. That will illuminate because the electrons being shot out of here can bounce off of that. If there's nothing to bounce off, they stay away from each other and they continue on through space as energy particles in an unseen state. They're unseen because they're not reacting. That's all it is. But they're energy and they're particles. That means they are dark energy because you can't see them. And there's dark matter because the particles are matter. They weigh approximately 0.00549 something atomic mass units. Very small, but there is such an enormous quantity of them coming out here. So what does that do? They're in here, they're unseen, but they are the ether. So out here, we'll grab onto anything that's out here. They'll light it up. They just light it up as quick as it can go because it's just flooded with electrons. Now, what else happens? These are negative particles coming towards the Earth, which has sucked up every negative particle that it can take coming in, and it creates its own magnetic field. All right, you understand? The positiveness of the Earth attracts the negativeness of these little bitty particles until they collect so strongly that you get the ionosphere and you get all this extreme layering of electrons that cannot get into the Earth and want to. And that creates our magnetic field. And they collect on the poles strictly because of the matter of the spin of the Earth. And that's the nature of particles, which the Earth is made out of particles. It's going to create a polarity as it spins. The more it spins out here, the bigger the polarity. The less it spins up here, the less the polarity. The bigger polarity has to find a way home. It comes up to the smaller polarity. It's as simple as that. It's very simple, really, if you can get rid of neutrons and Einstein. Because Einstein said, oh, light can't go faster than such and such, and E equals mc squared, but light has no mass. Well, if you even can do math, if light has no mass, then E equals mc squared says that light has no energy. So Einstein proved himself wrong. And there's all kinds of problems. But you get rid of the neutrons, get rid of the speed of light problem, and just watch the things I showed you, and its case is closed as far as I'm concerned. Somebody can come up with a better explanation. I'd love to hear it, but the only explanation they can come up with is, oh, leave us alone. We don't want to hear about it. So that's the way it works. I know showing this globe is going to have a bunch of attacks on me from Flat Earth. It is their way.